Okay, so they want us to sketch this graph. And so it looks like we have a stretch factor, and we have a change in the period, no phase shift this time, and then the whole thing's going to have a vertical shift up 1. Okay, so the absolute value of A is going to be 2, so that's going to be the stretch. And then the period's going to be 2 pi divided by pi over 2, which is going to be 4. And then there's going to be a vertical shift up 1. So again, you can make like a little regular cosecant curve here if you want. So think about being here at 2 pi and pi. And then the asymptotes for cosecant are at 0, pi, and 2 pi. And then the graph is going, you know, like this. And then down here like this. Okay, that's a quick sketch. Okay. Now I'll try to do a little bit better job here. All right. So we know the period is 4. Again, notice that it's not 4 pi, it's just 4. Okay, so we'll go out here at 4, and we'll mark that off. So I'm going to go with that kind of easier system. I think it's a little bit easier. Think about if this is the beginning of the period, here at 0, and this is the end of the period. And you could plug in values. You could plug in a 0 here, and then you could plug in 4 and see that they're asymptotes. That would be fine. Okay, but we'll just leave it at that. Now, cut that in half. That's going to be 2. And then that means your other asymptote's going to be right there, halfway in between. And I should have done this on some of the other ones, but I was all worried about using the asymptote formulas. Okay. So that's that then. We're going to go halfway between 0 and 2, and then halfway between 2 and 4, so 1 and 3. But we don't have to write those in if you don't want to. All right, and then we're going to have, it would normally be up here at 1 and down here at -1. But because of the stretch factor, it's going to go up to 2. Okay? But then there's a shift up 1, so it's going to go up to 3 now. Okay, so now my first point then is going to be right here at 1, 3. And again, if you wanted to, you could plug in an x of 1 and see if that works out to be 3, because it should. Okay. You might be saying, well, how would I do that? You would write it out. You'd go y equals 2 cosecant pi over 2 times 1, because that's what we're plugging in for x, plus 1. This is like my x value right there. So that means 2 cosecant pi over 2 plus 1. So now I have to remember what the cosecant of pi over 2 is. It is 1. Yeah, it's 1. Took me a minute. And then I get 2 plus 1, which is 3. And that's the point I have. Okay, so you can do that for all of them if you want, but I wasn't going to. Okay, now we're going to think about plugging in a 3. You know, what happens here at 3? Well, normally it would go down to -2. So normally it would go down here. But because the whole thing's shifting up 1, it's going to wind up being right there. So again, you could plug that in, and it'll all work out. And we just try to sketch those U-shaped curves in as best we can. All right, not too bad on that one. And then this problem has a little bit more to it. It says, what are the domain and range of this function? Okay, so you could say the domain is going to be all real numbers. But x cannot equal the even numbers, right? Okay, so even x cannot be an even number k, where k is an even number, even integer. How else could you write that? In interval notation, sometimes they'll write it like this. They'll say, like, it's -2 to 0, and then union 0 to 2, and then union to the 4, and then they just put little dots to show the pattern, okay? Or you could do it in set notation, you know, kind of like how I have it written there. Okay, the range. So what is the range? Well, it looks like the range is going from negative infinity up to 1, bracket, oops, negative 1, bracket, and then it's going from 3 to infinity. So wanted to talk about the domain and range on that one.